Problem 4. Two sources of electromagnetic radiation are in phase and emit waves that have a wavelength of 0.44 meters. Determine and give an explanation whether constructive or destructive interference occurs at a point whose distances from the sources are, and then A, B, C, and D. So in this case, we're going to use a similar equation that we've been using, which is this difference in phase is equal to 2 pi delta x over lambda. And what we're curious about in this case is just the change in phase. We want to know if it's off by an even integer of pi or an odd integer of pi. Even, of course, will correlate to constructive interference, and odd will correlate to destructive interference. The difference in this case is delta x. It's not essentially the path length in this case. It is the difference in path length between these two objects. And it really is just as easy as saying, for part A, we have delta phi is equal to 2 pi times delta x, where delta x is going to be the distance from the one electromagnetic radiative source, minus the distance from the other, divided by the wavelength of light we're concerned about, which in this case is 0.44 meters, and what this comes out to be. So we're eventually going to get 2 pi, and 3.08 minus 1.32 comes out to be 1.76, I believe, divided by 0.44 comes out to be 4. So ultimately, when we multiply by 2 pi, we end up getting a phase shift of 8 pi, a phase difference of 8 pi, which is even, which means we're going to get constructive interference. For part B, we're going to do the exact same thing. The only difference is the values we're plugging in for delta x. So delta phi in this case is 2 pi times 3.33 meters minus 2.67 divided by that same 0.44. And in this case, we arrive at a value of 2 pi times 1.5, which comes out to 3 pi, of course. And because this is an odd integer of pi, that means we're getting destructive interference. Part C. Do the same thing with just a couple different numbers. 3.74 meters minus 2.2 divided by that 0.44. What do we get here? We get 3.5, which times that 2 pi gets us a 7 pi. Once again, an odd integer times pi is going to get us that destructive interference. One more time. Delta phi is equal to 2 pi, where we have 4.18 meters minus 1.10 meters divided by 0.44. This is going to get us 2 pi times 7. So in this specific case, I would tell you to be very careful, because if you were to do this problem on a test, it's very easy to perhaps only do this portion, the latter portion, and you wind up with a 7, which is of course an odd number, and then jump to the conclusion that you have destructive interference. But you have to remember that multiple of 2 pi, right? It's these halves that give us destructive interference. If you just have 7, although it's an odd number, when you multiply by 2 pi, of course, you're going to get 14 pi, which is of course an even number. So that's just one thing to be a little careful of. You might not notice it if you're trying to work quickly through a test. And so that's a good thing to keep an eye on. But either way, this problem really is as easy as this. And that does it for problem 4.